Hello explorers and welcome to another video. Today we are going to continue building Linux. So those were the commands there. Let's go on and install this util-linux that I talked about should contain the kill command. So util-linux. And here we first start by creating a directory in our var lib for the hardware clock. Okay, and then we need to remove earlier created symlinks in the include directory for block ID, lib mount, and uuid. Okay. And then we should configure this one. And here we will run it with an adjusted time path to the hardware clock directory that we created, adjust time, and a documentation directory. We will disable cnfn chssh, login we will disable, no login, su, setpriv, run user, pylib mount, static python, systemd and systemd system unit there. So all those we will disable and be without. The disable and without option prevents warnings about building components that require packages not in the LFS or are inconsistent with programs installed by other packages. So we will install the Linux utils except for all of these. So we will not have su, we will not have the login or no login command. So I wonder where in the LFS package these will actually be added. So now we have disabled a lot of things, ran the make to actually build this one. Yes, and then we need to run the tests with nobody. So running the test suite as the root user can be harmful on your system. To run it, the kernel may be available running system. We will run that as a nobody if we will run the tests. So this was the utils package. Here we have add part, which will add a partition. I have never used that. I use fdisk for those kind of things. We actually have fdisk in this command package as well, so that's good. That we used in the beginning of this little Linux tutorial series where we created our disks. We also have the fsck, and this is a check and repair file system command. And there is a lot of different versions of it. We only have the normal and the C, RAM, FS, and Minix here. And there is other packages that will give us other versions of this one for the different file systems that we are using. We have the kill command, which is used to kill processes. That is used a lot. There's so many commands here. Jesus. Rename I use for renaming files, of course. Swap on and off. We used that earlier when we had created swap partition and wanted to turn that on. We have the mount and unmount, where we are mounting different disk drives or network drives and so on. So that's very useful. Those are the ones that I use most commonly. Eject is used for ejecting removable media. Dmesc I use a lot to check the kernel boot messages. Very helpful if you are debugging a startup. So that was make, right? Yeah. So now we need to change over so everything in this directory is owned by nobody. And then we will run the packages the test as nobody with the current path. So let's see if the tests will go through with that setup. Yeah, there is a lot of interesting. We have actually a command called cal, which will show a simple calendar. That's an interesting one. I want to run that later on to see how that actually is shown in a text environment. That's interesting. We have del part for deleting partitions. Have I missed anyone that I usually use? ls CPU, yeah, so check which CPU architecture is available. Do we have any more? We have the more command for text output that we talked about earlier. Make swap. Yeah, so many commands in this package. Yeah, it's totally the utils package. And all 200 tests have passed. So let's do a make install. So now we have all those different commands in our Linux environment. So that's nice. There were a few warnings for this one. So let's look at the cal. Ooh, yeah, that's nice. So you actually will see. So do we have any flags here on cal? Only show a single month. Monday as the first day, of course. Show week numbers. Yeah, this is useful. I will use that one. But with an alias to put this on, because Sunday being the first day in a week is just weird. And you want to see the week numbers if it's useful. I always forget which week it is, so that's good that I can go to the terminal and get that information. So let's see here. Well, next up we need to do e2fsprogs. Let's unpackage that one. And we need to create a build directory. So this is one of those. Haven't done one of those in a while. And then we will configure it with a lot of disables. So here we did it with the prefix of USR. We did it with a bin directory of bin with root prefix and no root prefix. We will enable elf sysklibs. That creates a shared libraries which some programs in this package use. With the root prefix, certain programs as FSCK program are considered essential programs when, for example, USR is not mounted. These programs will still need to be available. They belong to the directories like lib and slib. So when I've done that, we will need to do a make and a make check. Let's run those. So elflibs creates shared libraries, yeah. And then the other disables that we have here is lib blkid, lib uuid, uuid, and fsck. And these prevents e2fsprogs from building that and install the lib uuid the different libraries that I mentioned, and the FSC wrapper as a util-linux installs more recent versions. So it's interesting that the actually different packages comes with the same kind of functionality in many cases here in Linux. So you actually need to disable some functionalities. So the e2fsprogs package contains utilities to handle the ext2 file system, and it also supports the ext3 and ext4 journaling file systems. I believe I set up my root as an ext4 for file system, so it's important to have this one. And this one can search for bad blocks on your devices. It can debug your FS file system. It can run e2fsprogs, so actually will search the file system for failures. And I usually run this fsck .ext2, ext3 or ext4 in order to test the system, because then you will actually run it with the flags required for those different file systems. You also have the make file system, mkfs, for the different ones. So if you need to create new file systems or new partitions, you will use command from this package. So this is pretty much what this package is all about. It's the file systems that we usually use in our Linux environment. This is a 1.6 SBUs, so I'll get back to you when it's built. And we are done. All the tests have run and they were successful. So let's make install to get all the goodness into our system. And then we need to install the static libraries. So install libs, we need to run that command. And then we need to change the mode of some files. We need to change them so that the user can write them. And these are the, in USR lib, we need to update libcom_r, lib e2p, libx2fs, and libss.a. Why? I don't know. But we changed those up. So, okay, so they are not writable. So all have 444. That's good. And then we need to unpackage this libx2fs info file, and we install that info file to get that into the system. And if desired, install some additional documentation. So if we are running some more of these commands here, we will get more documentation into our system about COM errors, I guess. So let's run those so we have all the docs we can require. Next up, let's go to the next package. We will install sysklogd. Let's see here. First off, we need to remove some error. Fix problems that cause a segmentation fault under some conditions in klog and fix the obsolete program construct. Okay. Error loading kernel symbols. Remove that error message. And also remove a union weight and set that just to int. Okay. Let's make this one. So there were no configuration script for this one. And it's a very small one. And this sysklog package contains a program for logging system messages such as those given by the kernel when unusual things happen. So when we have done that, we will run the install, and it will just throw in the actual file and some documentation. And we also need to configure this one. So we'll create a configuration file for this, where we say that some logging for authentication will be done in the log auth, var log auth. We will have some some things from the before things are authentication will have be in the sys. We will log all daemon calls to the log daemon, kernel to log kernel, mail to log mail, and user to log user. So those are the different log files that will be run. So there's klogd as a system daemon for intercepting and logging messages, and then you have sysklogd, which logs messages and offer for logging every message is contained. So this is just a system logger that we installed. Important, and there is a lot of system loggers. I guess they chose one that is pretty small and pretty simple, but there are a lot of them out there, and some are more capable, and depending on how you want to set up your system, you might want another system logger. So this is just the one that they suggest. So let's install the system init file here, and that when we go into it actually requires a patch, so we need to install that too, and add the extra directory here. Removes several programs installed by other packages, clarifies a message, and simplifies compiler warnings. And this is also very simple, so it's just make and make install. Also a smaller package, less than 0.1 SBUs. So it just installed. And this contains power off, reboot, run level, shutdown, halt, and other good programs. I have used shutdown mostly and reboot sometimes. You also have kill all file. All five, but shutdown -H or -R for reboot, and then now is a very useful command to shut down your system. I use that a lot, and we will be required to do that later when we reboot the system. Next up, we'll do eudev. So first off, we need to do a little bit of a configuration here. Add a workaround to prevent the tools directory from being hard-coded into the eudev binary files library locations. Yeah. So by creating this config cache file, we will remove that requirement. I don't really see why it would prevent it, but yeah, just go with it. And the configuration here, we have the prefix of USR, we have the bin directory, the sysbin directory, the lib directory, the sysconfiguration directory, libexec directory, and then the root prefix, which is nothing, root libdir, enable man pages is good, disable static, so we will not do that, and configure cache, that's the thing that we did up here. We say that we want to use that cache file. So let's configure that. When we want to make this, then we want to make it with the library path in tools. So that's interesting that we continue to use tools as our library path, libtools, when we are making this. And this should also be a short one, 0.2 SBUs. But there is a lot of setup after this one. So this eudev will contain the eudev admin and eudevd. So this is a daemon that listens for U events on the netlink socket, create devices, and runs the configured external programs in response to these U events. So it's a package for programs for dynamically creating of device nodes. Okay, and when we need to check this, we first need to create some directories that is needed for this test. So in the lib and etc directory, we need to create a rules directory. And then when we run the check, we will have the LD library path to tools again for the check. Still strange, but let's go with it. There, 2 tests. They made it. Again for the install, tools lib directory. So we will install it there. I guess it will not install in that directory. It should install in the normal directory. Yeah, but it still uses libraries there. Then we need to unpackage the udev LFS into this same directory. Install some custom rules to support files in an LFS environment. So let's unpackage those rule files, and then we will need to make install those rule files with this command. So we point out the make file lfs.lfs. So this is a specific make file for the Linux from scratch environment that we point out here. So make will run that specific file and the install command for that. That added some rules for CD-ROM and so on in the environment here. And then information about hardware devices is maintained with the udev directories. Needs information to be compiled into a binary database. To create the initial database, we run this command. So we still use this library path for some reason. udev admin hardware database update. So now we have a hardware database update. So let's see here. We have some debugging information in the different GCC, which could be smaller. And now we need to do some more stripping to remove some old files and symbols. Yeah, this is a long script here. Let's see, first place. Yeah. So let's just run this. So this will create a list of libraries to save. It will then go into the lib directory, and for all the save libs, it will copy only object copy, only keep debug, and it will strip unneeded from these libraries, and then yeah, so it will just strip out all the unnecessary craft from all of these different libraries that we had in this little script here, and then we also need to run this little script here before we can do the next stripping. And this is also to remove some debug information from different commands here. So let's see if we can. There were some file formats not recognized here, but most of them are stripped, I guess. After that, we need to clean up our temp directory. So we have a clean one of those. Now we will log out. Yeah, or exit to get out of this environment. And then we will go into the environment again, but with our new system files. So we will use the USR bin environment and go in, and we will start bin bash. So now we are in a ch root with all the new things that we have built. Then we should do some more cleanup here and remove static libraries that were not suppressed earlier chapter to satisfy regressions test in several packages. These libraries are not from bin, utils, blibs. If this, I remove them now. Yeah, so we can remove even more files. I don't think that I will remove more of the static libraries. They are not required to be removed, but you can do that if you like. I think I will stop here. And this video will be cut into smaller parts. So this will be multiple videos, and I hope that these videos in this series will help you learn a little bit more about the Linux environment, what goes into the Linux environment, what kind of tools and libraries you can find in a Linux environment, what you can do with the Linux environment. If you have any questions about Linux, leave them down in the comment section down below, and I'll try to answer them as to my best knowledge. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.